Hello and welcome to everyone who is joining us today for the next episode in our natural language processing series. So today's session is on the overview of Azure NLP solutions level 100. So welcome back to those of you who've already joined a few of our sessions, and to those of you who are new, you're also very welcome, and we look forward to having you with us here today. This session will run over the next 45 to 60 minutes. That's inclusive of any Q&A. So any questions you do have, feel free to pop them into that Q&A box, and we'll be moderating that throughout today's session and reading out some of those questions towards the end as well. Just a reminder to everyone that this session is being recorded and it will be made available to watch on demand on the Microsoft Reactor YouTube channel. So I'll share a link into the chat again during the session so you have that. Just a very quick note of our code of conduct for today. So just a reminder to everyone who is joining us to be friendly and patient to everyone who's joining today, welcoming and respectful, and obviously understanding of differences in any different points of view that we might see throughout the Q&A and the chat today. So our speaker today is Lida Gavramalu. I'm sorry, I'm pronouncing that wrong, Lida. But Lida is joining us from the Cloud Solution Architect team and is an AI specialist. So really excited to have you with us here today, Lida. And she'll be leading this session for us. So just to give you a very quick overview of where we are in the series, and today's session marks episode number 3. Of this session. So we've already looked at rom-com or not level 2. Last week was slaying machine learning with Buffy, and today, as I mentioned, is an overview of Azure NLP solutions. You can see what we have on next week, and then throughout the rest of the series, these are some of the sessions that we'll be covering as well. So I will just drop a link into the chat of where you can access those sessions in a bit more detail on how to register too. So without further ado, I'll hand over to you, Lida, to kick us off. So I'll stop sharing my screen now.
Right, thank you very much, Emma, and hello everyone, and thanks for joining this call. After Easter break, we didn't expect quite good attendance, but it's great to see this turn up. I'll be having this conversation today for you with the overview of Azure NLP solutions, and as it shows on the slide, it is just sharing the slide. Yes, it is a kind of a level 100 course, but we will continue on advancing this topic over the next 6 weeks. So please stay with us if you are more interested in more advanced topic. But this one is mainly an overview of our technologies. And I will talk in through 3 sections. The first section looking into what is NLP, and a quick overview of AI timeline. And then I will give you an overview of Azure AI platform. And in section 2, I will detail the cognitive services and bot agent knowledge mining solution, and also the deep learning techniques that we provide in our platform. At section 3, I will provide you with a mapping between NLP techniques and Azure AI, and how Microsoft AI and NLP portfolio looks like. So feel free to ask any question on the chat. We will have time for Q&A, and I'd be happy to answer your questions. So let's start by what is NLP. It's a field of natural language processing. It's a field of artificial intelligence model, machine learning, and computational linguistics. The primary goal of the field is to interactions between computers and human in natural languages. It is often mistaken that NLP is all about text, but speech is actually an important part of the field, because humans communicate through conversations as well. And the main objective of NLP is to for computer to understand, analyze, and potentially generate large volumes of human languages. You use NLP in your everyday activity. You may not be aware of it. Just giving you some example. Whenever you do a search on your on your search engine, the recommendation that it comes through is an NLP application. My apologies, it's just so the auto corrections that your email provider suggests, that's also a form of advanced NLP techniques. One of the basic NLP techniques is a text classification, which the famous example for it is how your email are categorized through inbox and junk, and that's again an NLP activities. So especially in today's world, because the NLP is becoming a very on demand, and with the new advances of NLP, which we review in next slide, this field has become more and more on demand. So let's go have an overview of AI timeline, this keyword, that key phrase that often sometimes used as a buzzword, AI, but just an overview of what is the timeline. The field has started in 1950s by the curational leaps programming, and at the same time in an English mathematician, Alan Turing, has started the conversation, and very popular article that he published, and which is known as Turing test. So the idea of Turing test is if you put a computer in one room and a human being in another room, and there will be a third person who asks questions on each of rooms, the answers should be that close that the person in the middle wouldn't understand which one is computer, which one is human being. So as you see, it's a great expectation of AI at that point, and they have a lot of kind of promises at 60s era that they would think that artificial intelligence is here to rescue the society and be the kind of the hero. But in 1970s, the field has unfulfilled promises, and the expectation kind of didn't meet. At 1980s, by the introductory and the kind of start of machine learning, AI becomes a part of an industry. Machine learning mainly is a field of understanding what machine generates, and because as humans, we are very good in analyzing the data, but we are not good in volume of the data. We are not good in computational analysis, and also when the volume of data is a lot, our brain takes time to analyze that. Hence, in this scenario, machines are the great algorithm and programs that can analyze the data in a very fast time. So this is the kind of introduction of machine learning, and it's of course is kind of gaining intelligence from data to gaining insight to the from data to kind of information from data. So the field is very active still to this date. Machine learning, there are many algorithms in that era, in that domain, and people spend like years on universities to just kind of optimize one algorithm in machine learning. And the more the field got mature and the new algorithms added and techniques, the more need of having a computational analysis and also advanced analytics was more and more on demand. In particular, deep learning active research started from 2000, where is basically a imitation of how human brain works. And in deep learning, we had neural network, which is layer by layer of data are being analyzed by, in particular, architects, and it's a very active field. So in that domain, we can see that how in 2010, around that time, with the introduction, with the kind of emergence of cloud computing and big data analytics, the computer science domain becomes so powerful and needed much and more kind of attention and get more the main field of industry as well. NLP in particular, the active research of NLP started around 2011. By active research, I mean NLP has been even much longer than machine learning and artificial intelligence. It has a very old history in terms of computer science topic. But a particular forms of NLP that would require deep learning, and it's not only based on the grammar and part of speech and classical NLP. It started around 2011 by IBM Watson Machine when defeated the human players in Jeopardy games. That was a momentum for NLP skill, for NLP era. And it follows, the success follows by Apple Siri, Amazon Alexa, Microsoft Cortana, Google Assistants in following years. So as you see that in the industry, this becomes suddenly a main trend of how virtual assistant come into play to try to understand. And at the same time, in academic era, we have the kind of the architect of LSTMs, word embeddings, and attention models, which was all like kind of a very advanced understanding of how to analyze the context of the word, not just analyze word by word or neighboring words and so on. And in 2017 onwards, we have the kind of automated machine learning and also the concept of advanced analytics. Google Brain provided AutoML Cloud, which has Vision and NLU. It followed by Microsoft Azure AutoML, which cover classification, regression, and forecasting. And at the same time, in Microsoft, we have human parities that I'm going to discuss it in the next slide. And kind of the field again has more techniques and more capabilities to offer end users. And also the main thing that happened in 2019 was the introduction and emergence of transformers, which one of the famous language model, BERT, was introduced by Google at that time. And the idea of transformers, that they're looking into the context of the word to helping with language generation and question and answering, rather than just looking at the grammar level or even looking at the LSTM level, is much more advanced. And of course, in 2020, we have GPT-3, which is the largest language model that has been generated so far. And we will have a brief touch on that as well today. And there will be a particular session later on in this series that I will look into GPT languages, that how they are being created. So feel free to join that as well. So by looking at this AI timeline, you can see how the field has been advanced and why it's so important today that we understand what are the technologies that can help us with our NLP application. So in Microsoft Azure AI Cloud, we are quite proud that we cover all these three areas. So it started from apps and agents with Azure Cognitive Search and bot services to knowledge mining, which is the capabilities of our cognitive search and form recognizer. And then it comes to machine learning with the capabilities of Databricks, AML, and also our infrastructure. So this field is at any of this area, you get you can start with like out of the box capabilities, pre-built AI skills, to custom AI, which is more advanced and helping you to get to the point that you want to be applied. So that's a kind of variety of usage that end user can apply based on their skill set. So as the AI momentum, we have the human parities at different levels, starting by 2016, object recognition, followed by speech recognition, reading comprehensions, machine translation, speech synthesis, and understanding human parity until to a complete kind of reaching to a very high level of human parities in 2020. What do we mean by human parities in a way? I want to give you an example here of machine translations, and of course there are links here. This session will be recorded, so feel free to check the links, and there will be one link GitHub repository that you can find all these links there. I will share it on the chat. So this is a Chinese paragraph, which I'm not Chinese. I don't know the content myself, but we have two different translations for it. Which one of them is human, one of them is machine. And I'd like to give you a second, like maybe 2-3 seconds, just to use your brain to see which one is human, which one is machine, do you think? And feel free to put questions on the chat or something. Okay, for those who have guessed, the first one is actually by machine, and they're quite very close, as you see, and there are some, for example, there are some changes, like machine says US team, human say USA, and but they're quite accurate on a lot of details, and also there are like kind of notice that like something like at the end the phrase like possibility the best ever, we say possibility of all the time. So it's kind of, the point here is just to tell you that the machine translation is quite as close as human one. So we can claim that we have reached that human parity in this technology. And the other very active area, of course, in conversational AI, Q&A, we have reached in a very close close level in that one. It's just some of the examples here, and of course in industry you see every day the virtual assistant and conversational AI application that are available to you at any point on your mobile applications or on the bank that you log in. So all these all kind of the intelligent agents that responding to you, and it is learning through the conversation at the same time. It is not a static knowledge base. This is also a kind of an example of how this criteria has met. The other field that is quite active is GLU, General Language Understanding. And of course, no time to go through all these capabilities and all these tasks that we can do. But just to give you another example here, there's a sentence here that is asking, like the sentence is quite clear, the city council refused the demonstrators a permit because they advocated, right? So the first question is, who is they in this in the first sentence? And I guess we can analyze it and we can understand the question, but let's say how machine respond to it. Okay, the machine answer correctly. They here is the demonstrator, right? So that's a clear kind of, this is understanding that how the verb after the subject is understandable by in the whole context. It's not just part of a speech tagging because it could choose the other subject. To prove that point to you, I do another question here. So I ask, I just changed the verb and I said they feared, and they again the same question, who is they here? So if this machine wasn't intelligent enough or wasn't considering the change of the verb, the context, it should probably answer the same response. But at this point, it is actually changing the response because it understands the content of the verb. It is referring to city council. So this is a kind of a very quite advanced human parity in NLU, and how in language model actually train to kind of respond to this high level accuracy. That's quite impressive. Right. So now I have covered some of the kind of foundation of kind of example and overview of the of AI and NLP. Now I want to give you more deep dive on our technologies. So in Azure Cognitive Services are a kind of API level out-of-box solutions that are we are active in 5 main areas, and they're gonna add more on GA. And in each of these vision, speech, language, decision, and also web search, you can see that there are a number of API level access that helps you with your applications. And to give you a more overview of what is actually in each of these techniques, each of these words, you can see that they are either a container support or customizable support. Some of them are still on preview, haven't been on GA, but the roadmap will be updated quite soon on all of them. And as you see, for example, something like computer vision, which is one of the most active cognitive services that are being used every day by our customer, the same as our speech capabilities, face detection, language, text analytics, anomaly detector on decisions making, personalizer, and also very good activities now on Bing customer research that also link kind of match with our cognitive search capabilities. So these are all like the applications that you can easily apply and use it. And I highly recommend you just go to azure.com/cognitive services, and you can get just a free demo on each of these that are available on GA right now. So the great thing about cognitive services, you can deploy them anywhere using the container. So that's also giving you the freedom of cloud. It doesn't have to be binding to the cloud. Once you reach to the accuracy that you want and you are happy with the service, you can deploy it at anywhere that your data reside. The second part of AI and apps agents are Azure bot services that I kind of briefly touched it on Q&A. So today our bot development, we have a SDK Microsoft bot framework that is over 2 million of developer has been downloaded and been working on it. If we get around 4K community commits around time by this bot framework. It is implemented in different languages, C#, Python, also JavaScript, and it also very easily deploy and manage. And you can link the bot framework to active bots. And just to give you an kind of idea of, we have just this is the kind of report from our corp that weekly we get 3K bots being created by our organizations. So the other capabilities that we have are language understanding LUIS, which is a very rich system. It's a really rich application. It does the understanding. This is a link for you if you want to search. What LUIS does is basically work with intent and the utterance. The utterance is the conversation that you ask questions of the machine, for example, book me a flight, and the intelligence behind Louis is able to understand what is the intent, what is the entity, and give you an answer based on that, like it give you a confidential score. There is like much more advances on Louis these days. We have kind of document classification added to Louis these right now, coming on to GA soon, and also quite a advanced Q&A, not a static now knowledge base. You can kind of have a communication with the bot and keep improving it by the intent that are being generated and suggested. So it's a very good service that our customer are being using them every day actually. The second section that is pre-built AI that are quite active in our domain and having more attention is form recognizer and cognitive search. You may still see in some of Microsoft documentation form recognizer as seen as cognitive services, but because of the capabilities that it's quite advanced capabilities it has, I categorize them as non-knowledge mining, and the corp agree with us. It's just that they need to update the old documentation, but it is it's kind of an form, it's an item of our kind of non-knowledge mining offer. So what basically our form recognizer can work with any type of forms, and what they do is they extract tables, text, and key value pairs with just a simple REST API. And there have been the insight that it uncover from all formats, all types of form that you see it here, and we have many from healthcare domain. We have customers that are actively using this service to digitalize their form, their patient form. From insurance and financial services, we have many companies that they have kind of insurance form and they needed us to kind of help them to analyze these forms. This has been using for that. And form recognizer has 3 different layouts, which each of these services has been updated even from the time that I created this slide. So please feel free to go and check on updates. So there's a custom model on it, and it also enable you to do the auto labeling and with the ground truth of your data is something that I personally quite interested to apply for our customer. And then there's a kind of a layout. When the form layout is quite clear, the kind of the form recognizer can easily access to it. There's also a pre-built, which is particular for invoices, and a lot of retail companies are being used that, and it's on GA. It's a very powerful layout at the moment. So feel free to check on different types of the form, and it's been quite advanced services, which is on NLP domain. The other services that it's very good in terms of helping with knowledge mining and especially information extraction is known as Cognitive Search or Azure Search. So what it does, basically, you can ingest all types of data that you are interested and you have. And after that, it kind of enrich all the documents, it indexes them. And by enriching, meaning that it identifies the entities, the name entities that are then it could be as simple as name of the countries and kind of location. It can be by organization name, by human and person name. Also, it can be customized by your custom skills, like if you have particular entities that you want to be identified. For example, let's have a taxonomy of drugs for a pharmaceutical company, and at the same time you got the kind of the duration of and then after the enrichment level it does the indexing, and at the end you had a kind of a search that search capabilities that you can question complex query, and then it will be able to answer that. And let's have a deeper dive on Azure Cognitive Search. So you could see it's kind of start to maintain a scale. So this is basically you could start with different Azure data storage. You don't have to have a very complex storage complex. You can start as simple as our blob storage and then build on top. And it's quite easy to configure it. It has a very easy UI setup. And of course, you can do it through REST API and the coding as well. And then, of course, you can do the enrichment and out-of-box capabilities, for example, connecting it to Power BI dashboard and other capabilities that are kind of just by offer. And then it can be also a scale out as well, easily scale out and maintain. So in terms of integration, the great thing about cognitive search that it has the kind of the vision. It uses the cognitive services as a backend. So we're still using the vision API, language API, text analytics API at the backend. That's why always when you have an Azure search item, you have a cognitive search product as well to link together. At the same time, it also does the orchestration. So with this orchestration, it's actually very powerful in a way that you'll get all the entities and the key phrases that are extracted through the knowledge store, and that enable you as a kind of a data scientist or let's say an NLP expert, if you want to dig in more into these indexes, it enables you to look into those tables. So that's a great way to kind of use the outcome of Azure Search, which is bringing us to the final part that you can do the customization on that. So after you ingest your data, you ingest and you enrich it by cognitive services, and it does the indexing for you. You have the capabilities to use the JSON outcome of your search query or even the tables that are being generated in knowledge score and apply to any other tool, for example, to TensorFlow, to our AML machine learning notebook capabilities, or even Databricks, for example, particular regex if you are interested to apply some custom skills on top. And then again, the outcome would be a JSON outcome, and you can just work with it. So this is, I believe, this is the main power of Azure Search that differentiate this product with other product in the market. And of course, you can always do the specific industry and kind of task and what you want to do. All the links, as I mentioned, is here, and the final link that I search on Google on my GitHub repository have the links to these services. So some of the knowledge mining scenario that we keep seeing from our customers are, for example, auditing and complaints, technical content overview, customer feedback analytics, digital asset management, process management, and catalog search. So these scenarios are each need different requirement, but the power of the product that it can kind of understand all of this and can help you with them. The final part that I like to touch on is the concept of deep learning. So far, these services that I discussed with you, they don't cover the advanced analytics on kind of the deep learning. They are just at the level of machine learning and advanced NLP. So if you have a particular application on machine learning, so these are all the machine learning capabilities that we have right now in Azure. At the first layer, we got all the cognitive services that I have already covered. At the data science level, we got all these capabilities on deep different environment for you as a data scientist if you want to work. And feel free to check this link, and this will get you all the current tools that we have as a data scientist you like to work. And of course, if you have an NLP algorithm, the popular frameworks that we cover, PyTorch, TensorFlow, scikit-learn, MXNet, Chainer, and Keras. Keras is a famous libraries that being used a lot in deep learning and also NLP in particular. And as you see, we also have a kind of adaptability to Onyx for people who kind of work on open source and want to deploy it on other platform. So this is also capabilities on that. In terms of productivity, our machine learning and Databricks are here to kind of help you to take your models to production. And it's and also it has a pipeline of MLOps and help you to build a pipeline quickly. And also we offer a number of machine learning VMs that has all the content, and people who work on NLP domain, you may agree, know that some of these, for example, library like transformer libraries are often difficult to install in a kind of a local compute. So it needs a lot of compute, and it needs a proper environment to enable you to start working on these libraries and language model. And our virtual machine are the environment that can help you with that. And of course, it's the infrastructure. We have the kind of powerful infrastructure. In text analytics, we often find CPUs are quite good enough. But if you want to, for example, do a fine tuning on a big, large model, you may need a GPU, especially if you want to do the deep learning. And of course, if you have an image analytics, you definitely want to go GPU. So you see that different series of infrastructure are available for you in Azure, and you can even think of FPGA, well, as very special hardware that accelerated the deep learning. So depending on the need of the infrastructure, you could choose. The part that I like to just touch at this point, and I don't want to go deep dive on that because some of these topics are being covered in the next few weeks. For when it comes to advanced NLP, we have a lot of important scenarios such as text classification. Name entity recognition can be done with different services, but you could apply name entity recognition, for example, with language model. There's a text summarization, which is a very important active research. Entailment, question and answering is one of the very application that I have a talk on question and answering later on in this series. Sentence similarity, word embedding, and also sentiment analysis. So these are like all like advanced NLP algorithms, and it's quite what Microsoft Research has done. They have a GitHub repository which you could go through it, and for each of these they have different scenarios. For example, how you can deploy them on AML, how you can deploy them on Databricks, and so on. So I highly recommend you to go through it. And because of the content of this topic, this talk, and also the kind of the level that we provide, I don't want to go through all these details, but these are available to you to look into, and feel free to attend in other talks. One thing that I want to emphasize here, we are at the era that May last year, we got the largest language model known as GPT that OpenAI research and Microsoft introduced a language model with 15.5 billion parameters. So just to give you an idea of where we were before this point, we had like the kind of around 2019, 2018, late 18, we got BERT, which was GPT was kind of smaller at that point, and then you get BERT as like 300 million parameters, and as you see, it get more and more advanced by different companies, and the research has been active, but the difference between the previous language model to GPT-3 and TNLG, which is higher than that. TNLG is just before the GPT-3 language model. So as you see that this is like kind of, it is like, it's a big jump. It's a very, very big jump, and it can, you cannot, like, we cannot, that is the kind of a momentum for NLP research. And feel free to read this article on this information, and you can, hopefully you probably have heard of it a lot, that what great things this language model can do. So I want to conclude my talk with a free mapping of these NLP techniques that we discuss and Azure AI solutions. And before I share this with you, just want to emphasize that this is my own understanding as a person who studied NLP in academic and spent years in industry in this field. So, and it's not necessarily a correct mapping, but it's just a free understanding of how these two can meet. So if you look at all the NLP techniques that we have discussed very briefly today, at the very high level in Azure, we got cognitive services, which is can answer question and answering, machine translation, speech to text, and text to speech. And then at the kind of more pre-built AI, we have knowledge mining, which also using some of the cognitive services. So still you have NER, tag extraction, OCR, but they do it in a more customized way. And because of the integration with other services, they can be integrated to other services. So, and of course, at the top, very quite a, let's say in this model, you have very advanced on deep learning and AML, so something like summarization, classification, topic modeling, word embedding, and so on. So you see that there are some overlaps is in these ones. So, and the area of overlaps is on different applications right now. So my comment here is, if you have a question and answering application, it's not necessarily you need to go directly to deep learning and kind of fine language model and so on. You could start with cognitive services and to see how these have been applied. The same thing happens, for example, for sentiment analysis or for name entity recognition and key phrases. So I guess the message here is, in the past, NLP was a very difficult topic to discuss, and applications need really an expert kind of SME, subject expert matter, to understand it and to apply it. Today, with the current technology stack that we have, you can apply this on different for different level and different skills, and you will still get a reasonable outcome of it. So I guess that's a kind of a comment and message that I'd like to give you, and also the idea that in Azure we have an answer for almost all NLP techniques that you may have. So I finished my talk with an overview of Microsoft AI portfolio. As you see, we have pre-built AI and custom AI. At the pre-built AI, you get bot framework, cognitive services, and knowledge mining, which is they all can be on CPU level, and you can have all the data storage that you can imagine. At the custom AI, we can think of notebooks, other IDEs, the tools that we have for AI infrastructure, Databricks, and Azure Machine Learning Services. And of course, you get the frameworks for deep learning, and you have the capabilities to train these models on different environments and deploy them using the containerizations that we have or on an IoT edge. And so this is like kind of idea, like I'm just trying to give you a thing that this platform offer you a number of ways to apply your training, and feel free to try any of these. And want to finish, this is the learning resources that feel free please to go to any of that. In particular, if you're going to this this GitHub, I probably try to share it on chat very soon, but if you go to this GitHub, it's my own public GitHub, you find most of the information I share today on this GitHub, and in particular it has the link to all the other conversation that we just review. Thank you very much, and I guess I'm quite on time, so thank God for that. Emma and Robin, I am yours if you like to put the questions on me.
Okay, so we did have one question talking about how you do a more complicated decision process based on documentation.
Okay.
So I mean, yeah. So you go ahead. I kind of answered it by talking about Lewis a bit, but obviously maybe
sure.
more you want to add.
Yeah. So the question was on decisions on documentation.
Yeah. Okay. So let's say you have a document and you want to do a multi-step process based on what's written in the document. So if this happens, do X, then Y, then Z.
Oh, right. Okay. I think the first thing is you need to extract those information from your document. So then knowledge mining extraction, you can think of either form recognizer or Azure Search, which in this scenario, I probably recommend form recognizer, or as you point correctly, Louis would do that as well. At the moment, we can extract information from Louis. And then for the type that you want to put the condition on, it's a kind of, you could go like train some intent on Louis to become like more intelligence that recognize the utterance, particular utterance, and apply some entities. Or you could follow the path of analytics like advanced analytics and NLP that you would apply, for example, some classification model into that particular categorization, like kind of sit between a classification model and of course in classification you can either apply fine-tuning model, or you could go for particular deep learning architecture that you could help you with that. So Louis form recognizer for knowledge extraction, Louis for entity intelligence identification, and also text classification.
Okay, thank you. So that was the only unanswered question.
Yeah, perfect. Okay. It's the one question. Can Louis understand long pieces of text? Very good question, Matt. I guess Louis in the past it was only for shorter utterance, but we have a preview model that I worked with it, and it hasn't been on GA yet. I think the roadmap is coming to GA around June, public preview. So that one, yes, that one it enable you to do a training on long sentences, long pieces, and after you train your model, it enable you to kind of remember the conversation, and they kind of it's a kind of a machine learning training at the same time giving a feedback loop. So yes, it has enabled by long pieces, and it's also at the back end. Also, I know for the fact they're enabling with some transformer architecture as well, which is suggesting that they're enabling that the capabilities of language model, and when language model are applied as a fine-tuning, it can definitely understand the long pieces. Yeah, so maybe wait until June, you will have a public preview on that and try it. Yeah. Good.
Okay, so we do have a flood of more questions in.
All right, okay.
So next one is what kind of specific models are used to solve problems such as the they example that you used previously?
Oh yeah, that is I believe what they do on human parity on that scenario is they are enabling a kind of transformer architecture and language model. Microsoft itself has a very good language model known as Turing language, LNG. So once they apply, it's a kind of an attention model, like kind of it received the sentence, it received the, at one layer, it received the sentence, but it also looking into not only the neighboring of the words, it's looking in a particular part of the phrase, and even through that, because it's been already trained with a large corpus, it already understand that, for example, kind of the architect that use it kind of put the model into the attention to the verb in that particular scenario. So I cannot like advise on particular architecture they're using, but I know the techniques they're using is kind of context-based understanding, which is suggesting through transformers and attention models, and it is on the back end. So a lot of complex NLP scenarios you see today at the human parity, they apply this sort of techniques. So suggesting and looking to transformer architects, libraries, articles, and you may get kind of a better understanding of how this does. But it is different from LSTM and other deep learning architecture that are available before. It is more advanced than that.
And so we have another question. Can you talk a bit more about data security and privacy when using Azure Machine Learning and Azure Container Services? So this might be a question that's a bit bigger. So
yeah, do you want to add something first yourself? I see. How can I add more?
Yeah, so the normal kind of questions that we get with cognitive services is do we hold any of the images? Do we hold anything up there? So we only ever hold most stuff we don't keep. We do sometimes hold data for retraining, and I believe it's destroyed after 7 days, regardless of anything. We do have Microsoft Trust, which you can go on, and we should have some bits on there. In relation to Azure Machine Learning, that's it. We're just giving you an environment to be able to do your Python coding in. So it depends what you do as to how secure that's going to be.
Exactly. I think you covered it quite well. But I can only add that once you have a tendency with the cloud, it is your environment and it's secure. It's not that anybody else rather than you as a user would see it, unless you give access to different users. So there's a kind of a security level on that. And there's also, if you want to add per private IP on that, you can apply that as well if you want to be very secure, not even you could it enable you to do that. And as for your data, it always stay at the instance of the storage that you have on your cloud. Nobody else, and rather than your own as a user, would be able to see it. We just provide you the platform. So that's basically it. Yeah.
So we also had Matt Lee, thank you for posting that. It's multi-step Lewis example in the chat, and the last question.
Yep.
Second last question. How would NLP identify actions, commitments? How would NLP identify actions, commitments in conversations?
Identify action, commitments in conversation. Well, if I be answering this from the NLP space, I think we may need a kind of a longer conversation here, but I think it's probably, I'm feeling that you're kind of comparing to action commitments in kind of in a, let's say, in an agent environment. When I ask my kind of as a user, I ask the bot that book me in this calendar. So that kind of, let's say, that backend agent would have access to a particular instance of my calendar, and they kind of apply an action on it. So it's kind of an like in Dialogflow in Google, you could have a particular agent that you activate the action element on that, and similar way in Louise and Q&A we have that. So that's a kind of a type of the let's say the type of the intent that we identify it can be. But in terms of commitments, I'm not really sure what you mean by commitments here. If it is something that maybe if a little further because often we say actions and reactions, so something like that. Maybe I interpret it as that, and it really depends on the utterance. Often this language, often this Dialogflow, I believe, does the same, or Louise. They kind of understand the utterance first, and then within the utterance, they identify the particular, after the particular, the entities and the content of it. They might be able to just suggest, kind of learn something and act on it based on, as I said, if it's a calendar, it would act on it to book some appointment for you. But if it doesn't have the particular action to it, the bot might, kind of the conversation might be continuing unless you can give some access to the agent to apply to it. That's the kind of happening conversation. Would be good if I get more clarity on the question. I guess it's I hope I covered it in a general level.
Okay, thank you. So Matthew, again, thank you for posting a link on Azure Security and Azure ML. And then the last question we have today is, you've mentioned that AI services like computer vision are provided on Azure.
Mm-hmm.
Do such services require intensive coding, like, for example, using Visual Studio Code, or is it simplified?
Yeah, I think that was the kind of the message today. As many of our cognitive services, such as computer vision, I mean, depending on how you define computer vision. If you're saying just custom vision, our custom vision are kind of UI, has a UI capabilities that you can just go and apply your, like, you can like put your images and just give you a kind of train a model for you, and it does a deep learning, like it has a kind of quite a complex deep learning model behind it, but you don't see it, so you don't need coding on that. But if you want to apply proper computer vision with a particular architecture, then I would advise you to go to our notebooks, to Azure notebooks, and you apply VS Code, or starting doing proper Python coding, or any other languages that you are interested. The idea of cognitive services, they are out-of-box services, pre-built AI that you don't need to know the coding. You could just use them as an API. And that's just a message that we're trying to pass on. And you don't need to have the kind of a proper coding skills of a computer vision to be able to work our custom vision here. But the capabilities is there for you if you want to go deeper on code.
Okay, and so thank you for that. And that's the last question for today, and we are at time.
Very good. That's good. That's a very good communication to our people, and thanks again our colleagues who contributed to this session as well. I don't know how to post. Should I make an announcement? Yeah, perfect. I can probably just to post this. I mean, the user probably has seen this GitHub repository, but I put it anyway. So just for people just interested to just go and check on this link, and yeah, I think that would bring me to the end of this. And thank you again, Emma and Robin, for facilitating this, and all our great contributors and our listeners to this talk. Thank you very much for your time.
Thank you, Lida, and thank you everyone for attending. Hope to see you all again next week at our next session. Thanks, everyone.
Cheers. Thank you, everyone. Bye.